All right, guys, so today we're talking about exponents and a whole bunch of rules that go with exponents. Down at the top of your page here, you've got this box that says properties of exponents, and you've got 7 formulas that you need to learn. It looks like a lot. The good news is they're all very easy formulas, but they're new. They're ones that you haven't worked with a lot. What you've been working with is situations where we are adding a lot of things together. So you've been doing things like 3x plus 4x, and you've learned that to combine like terms, you add those together and get 7x. Or you've done things like 4y plus 2xy plus 7x plus 2y, and then you have to pick the things that can add together, and you're left over with all of these things that don't add together. They're kind of just stuck on their own. We're doing some similar things today. What we're going to be doing is giving you an expression, but instead of a bunch of things being added together, instead of a bunch of terms being added, we are multiplying everything. And on top of it, we have exponents. So instead of seeing pluses and x's, you are going to see a lot of multiplication, and you're going to see a lot of exponents to go with it. In fact, on today's homework assignment, you will not see a single plus sign. You will also not see a minus sign. You'll see negative numbers, but you won't see any plus, any minus. All right. So I'm going to go through each of these properties, and the property gives you kind of a mathematical definition, and I'm going to show you some more examples right underneath it so that maybe the definitions make a little bit more sense. So the first rule that you've got is called the zero exponent property. And it says that a to the 0 equals 1. Now on all of these formulas, they all have this a, which represents a number. Now that number on all of these formulas is what we call the base. So when you have an exponent, like if I have 8 to the 4th, this big number at the bottom we call the base. The little number at the top we call the exponent, okay? Even if it's not a number, even if it's a letter, if I've got x to the 4th, this is still the base. It has a base called x. It has an exponent called 4. So in these formulas, the base is always the letter A. So if you look at these, you'll see a bunch of A's everywhere. That just represents some number. That's the big number at the base, okay? So the zero exponent property tells you that any number raised to the 0 power is equal to 1. It doesn't matter what the number is. 6 to the 0 equals 1. 1,325 to the 0 equals 1. Pi to the 0 equals 1. Rainbow to the 0 equals 1. Okay, it doesn't matter what I'm raising to the power of 0, it always equals 1. So it completely gets replaced with the number 1. Okay, second rule is called the product rule. And what this says is if you are multiplying two numbers together that have the same base, so if they both have the same big number at the bottom, then you can multiply those together. All you have to do is add the exponents. So for example, I'll switch colors here for you. If I have x to the 4th times x to the 3rd, because both the bases are x's, I can combine those together by adding the exponents. If I have 6 to the 9th times 6 to the 2nd power, that becomes 6 to the 11th power, okay? It doesn't matter what the exponents are, you can add them together. If I have w to the negative 4 times w to the 10th, those can add together and become w to the 6th power. You add the exponents together. Okay, the quotient rule is the opposite. What if you have a fraction with numbers on top and bottom that have the same base? So for this one, I'm gonna do these examples over here on the left, okay? So for the quotient rule, if I have x to the 9th over x to the 3rd, I've got basically, I'm actually canceling things out. I've got x on top, I've got 9 of them being multiplied, right? X, 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 x. On the bottom, I've only got 3 x's being multiplied. So what I'm actually doing is I'm canceling them out, and I'm just writing down how many x's are left on the top or the bottom. In this case, it's x to the 6th power. So when you have numbers on the top and the bottom with the same base, then you just cancel out and get rid of the ones, the smaller ones. So for, let's go, let's say I've got y to the 7th over y to the 4th. I've got a bigger number of y's on top. I've got 7 of them. I've only got 4 of them on the bottom. So when they cancel, I'm going to be left with 3 y's on the top. If that switches, if I have, let's say 2 to the 5th power over 2 to the 9th power, I've got more 2's on the bottom. So when these ones cancel, I'm going to be left with 4 of them on the bottom, and I'm left with none on the top, so I just put a 1 on the top instead. Okay. Now, the formula tells you to take the top number and minus the bottom number. You end up with the same answer. I just think it's faster to look at what's on top, what's on bottom, and cancel them out instead of worrying about the subtraction. Okay, next example, negative exponents. This is the easiest rule, but it's also the one that you guys mix up a lot and struggle with for some reason. I don't know why. A negative exponent, we do not like having negative numbers up in my exponents. So to get rid of them, all I have to do is move them up a fraction or down a fraction, and that will change the negative number. If you notice, this has a to the negative n. When I move it to the bottom of a fraction, it changes it to a positive n. So if I have x to the negative 4, I can rewrite that as 1 over x to the 4th. All I have to do is move it to the bottom of a fraction. If it's already on the bottom, if I have, let's pick something else. Let's do 3 over y to the negative 8. The negative is on the bottom of the fraction. I can move it to the top by making it a positive 8, like that. 3y to the 8th. The y and the 8 move to the top, and it becomes positive. Okay, we love this rule because we do not like negative exponents, and this cleans them up. It gets rid of them. Okay, all right, power rule. The power rule and the product rule, you guys mix these two up. This one right here and this one right here, you mix up all the time. In the product rule, when you have two different numbers getting multiplied together, then you add the exponents together. The power rule is a little bit different. You've only got one big number. You've only got one base. So for example, this would be like if I have 5 to the 3rd power, and then I have another exponent on the outside of the parentheses. So if I have an exponent and I'm combining it with another exponent, so I have two exponents at the same time, then I multiply those exponents together. That becomes 5 to the 6th power. And it tells you that in this formula right here, n times m. You multiply those together, okay? So if I have x to the 3rd raised to the negative 5, I just multiply those exponents together and I get x to the negative 15, okay? Now, the power of a product rule and the power of a quotient rule, these two go together. These two kind of are the same idea. If you have an exponent on the outside of a fraction and all the numbers on the inside are being divided or multiplied. So notice there is no addition, there's no subtraction, there's only plus, or there's only multiply and divide. It's kind of like you distribute. You take this exponent on the outside and everything on the inside gets that exponent. It's just like distributing when you've got a number in front of the parentheses but you're distributing an exponent instead of a coefficient, all right? So a couple of examples. If I have, I'm going to do these ones down here below. If I have 3x squared over 4y to the 5th times z, if this is all getting raised to the 3rd power, that means everything inside, there's no addition or subtraction. So everything on the inside is going to get a 3 exponent. So I'm going to distribute that exponent to everything on the inside. So my 3 gets an exponent of 3. My x squared already has an exponent. It already has a 2. And now I'm combining it with another exponent, a 3, so I multiply those together and get 6. On the bottom, I've got a 4. I need to give it the exponent 3. I've got a y to the 5th power. That 5th is going to get multiplied by 3 and become 15. And then I have a z with no exponent, so it just gets the 3. Okay, easy rules. Now we get to have a little bit of fun, because what we're going to do is we're going to throw these big expressions at you, and most of the expressions you are going to use multiple properties. You're not going to just use one property. In fact, the order that you should do these in, step 1, let me get a color we haven't used here. Step 1 are these 3 rules right here. So you should always try those rules first. You want to get rid of any exponents on the outside of parentheses. Then you want to get rid of any negative exponents. That's going to be your step 2. Then you want to either do the product or quotient rule to simplify. And then at the very end, if there's any numbers left over, like 3 squared or 7 to the 4th power, you just put those in your calculator and change them into actual numbers, right? If it's something you can calculate, go ahead and calculate it. So let's try these. Example number 1. There are no exponents on the outside of parentheses, so I don't need to worry about that. All I have is 3 different numbers getting multiplied together with exponents. So no negatives, that's good. I'm looking for things that have the same base. This has a base of x, this has a base of x. So I can combine those together, and those x's combine to be x to the 10th power because I add the exponents. Now the y, there is no other y's, so it just gets tacked on here at the end by itself. Okay? Example number 2. No exponents on the outside of the parentheses, no negatives. So all I want to do is combine things together that I either want to do the product or the quotient rule. In this case, I just have a bunch of stuff getting multiplied. Sometimes it confuses you guys when there's parentheses. All we're doing is multiplying these numbers together. The 4 and the 5 multiply. 4 times 5 is 20. The x cubed and the x to the 6th power can go together because they both have a base of x. So those become x to the 9th power. All right. If I go down below to number 4, no exponents on the outside of parentheses, no negatives. All I've got is some quotient rule stuff. So I'm going to start with 6 over 18 because I graduated middle school and I know that 6 over 18 simplifies to be 1 over 3. If I don't know that, I type it in a calculator and the calculator tells me. So now I look at the x's. On the top, I've got x to the 4th. On the bottom, I got x to the 10, which means I have more x's on the bottom. So they're going to cancel out, and I'm going to be left with x's on the bottom. And I actually have 6 more x's on the bottom than I have on the top. So I have 1 over 3x to the 6th. Okay, number 3. This one does have an exponent on the outside. So first thing I'm going to do is distribute that exponent to every number on the inside. So the 3 is going to get an exponent of 4. The A already has an exponent of 5, so that 5 is going to get multiplied by the 4 and become 20. The B already has a 7, so that's going to multiply with the 4 and become 28. The C doesn't have any exponent, so it just gets a 4. And I stop right there. Number 5, I've got an exponent on the outside and a bunch of stuff on the inside. So first thing I'm going to do, everything gets that exponent, all of the numbers. So my 2 becomes 2 cubed. My n on top becomes n to the 21 because it already has a 7. My 3 on the bottom becomes cubed. And my n squared now becomes n to the 6. Now I simplify. Numbers on top, numbers on bottom, 2 cubed, that's just 8. 3 cubed, that's 27. Now I look at my n's. I've got 21 n's on top. I've got 6 n's on the bottom. So I've got more of them on top. So after they all cancel out, I'm going to be left with 15 n's on the top. So I looked at this number and this number. The top number is bigger, so 21 minus 6 tells me how many are going to be left on top. Okay. All right, number 6. I've got a number on the outside and some negatives. So let's deal with the number on the outside of the parenthesis first. This -2 is on the outside of this parenthesis that has the x squared and the y. It has nothing to do with what's on the bottom. So the bottom is going to stay the same for now. On the top, the x squared becomes x to the -4, and the y becomes y to the -2. Now, step 2 is to get rid of negative exponents. So all I'm going to do is move them. This x to the 4th is going to get moved to the bottom and become a positive. So I'm going to put a fraction bar, and I'm going to move that x to the 4th down to the bottom. What else do I got? Y to the -2. I'm going to also move that to the bottom and make it a positive 2. The 2 on the bottom, this 2 right here, is just a normal 2, so it just stays on the bottom. I've got x all by itself. That stays on the bottom. But then the y to the -3 that's down here gets moved to the top, and I put a y cubed on top. Now I combine things together that will combine together. So for example, I've got these x's on the bottom that are getting multiplied. So those become x to the 5th. I've got a 2 on the bottom all by itself. I've got 3 y's on top, 2 y's on bottom. So those are going to cancel each other out, and I'm going to be left with 1 y on the top. It's kind of like there's an exponent 1 right there. We just don't usually write an exponent of 1. Let's do a couple story problems. There are 8 times 10 to the 12th hydrogen molecules. So these are molecules in a volume of 4 times 10 to the 4th centimeters. What's the average number of hydrogen molecules per cubic centimeter? So I see a key word right there, per. In math, that means divide. So what this is asking me to do is take the hydrogen molecules and divide the cubic centimeters. So when I look at my problem, the hydrogen molecules go on top. So 8 times 10 to the 12th. On the bottom goes the cubic centimeters. So 4 times 10 to the 4th go on the bottom. Now I just clean up. If I look at my tens, I've got 10 to the 12th on top, 10 to the 4th on the bottom. That means I've got more tens on top. And so when they cancel, I'm left over with 8 of them. Now, the 8 and the 4 is just 8 divided by 4. That's just normal math. That just means 2. So my answer should be 2 times 10 to the 8th, which hopefully, there it is, shows up, letter H. Okay, if A, B, and C are positive integers, AB is equal to X, CB is equal to Y, what is x times y? So it wants me to take x and times y. Well, x is right here. It's a to the b power. Y is over here. It's c to the b power. But this does not match any of my letters over here. None of these match what I've got. So I need to simplify it a little bit more. This one's kind of hard to see because you're actually using one of the rules backwards, okay? Instead of working forwards, we have the end result and I'm trying to go backwards. So if you remember, there was a rule that said that if I've got, I'm going to use different letters than they used. If I have x, y to the a, then that equals x to the a, y to the a. So that's the rule that I'm using. I'm just going backwards. I'm going this way. I have an exponent on top, b and b. So it's kind of like I'm undistributing. I've got a times c, and I'm going to take that exponent b and move it to the outside. And now it should match with h right there in the middle. Okay, practice problems. They all look different on purpose. I know that they don't all look the same. I don't want them to look the same. I want you to see all of these different rules being used in very different situations. So what you need to do on all of them is try to use one of these rules first, if there's an exponent on the outside of parentheses, then get rid of all the negative exponents, then use the product and the quotient rule to cancel things out on top and bottom or combine things if they're on the same level. And then if you have any numbers left over, just nice numbers, go ahead and put those in your calculator to finish up the problem. So your answers are going to look like a mess. You're not going to get 7 as an answer. Your answers are going to look like a whole bunch of exponents and letters and numbers put together. So don't stress if it doesn't look super clean.